Good afternoon. Aloha. Nobody's from Aloha. All right. My name's Craig Field. I work for Defense Point Security. I do a little background on myself. I got started doing computer forensics when somebody just bought Encase and said we need somebody to figure this out. And it was great just to volunteer for it, and I've been doing it for over a decade now. And then once you find enough with forensics, the great thing is there's not a lot of people around to tell you what the malware does once you find it. So I'm really appreciative of people who have gone through and made automated tools to make my life a lot easier. So malware visualization, I run into a lot of problems in that, from junior analysts to managers to other reverse engineers and other organizations. The communication that we have is not very good. The words we use, what people associate emotionally, visually to one word means something different to somebody else. What they want to get out of something means something entirely different. So I'm understanding the absolute crucial value in knowing what a word means to your audience and making sure that they understand what you're trying to communicate. This one thing I really love is this quote. We're in the world of data. I saw somebody put something out that says the amount of data we've collected, out of all of it, the most we've collected is in the last 2 years. It's just amazing that we've just turned on sensors on everything, and now we don't know what to do with all of this, and we need more people that can do it. Einstein's quote I love, and it's based on a book, E = MC squared. If you want the shortcut version to that, Netflix has a good video called Einstein's Big Idea. And the point is it takes energy and all the scientists that had to figure out how to communicate what energy is and all the different forms of energy that we have, and matter, and C for celeritas, meaning the speed of light, and what the speed of light is and how it affects our life, and squared and whatnot. And he took all these huge different scientific ideas and was able to get one of the most powerful ideas down to something very short. And as he points out, I have no idea if he said the second part here. I got it from the internet, so obviously it's true. But I appreciate the thought in that we could always go towards giving more data to a manager who has to make a decision, or a junior analyst who's just getting started. But we really need those shortcuts of life to help us to better understand things, because at some point we're all idiots at something, right? So you need somebody to give you that shortcut to help you to get you to the next level. The book is called E = MC squared by David Bodanis. It's a local library, a wonderful, great book. And the Netflix version goes into all the men and women who helped create this. 15-year-old female mathematicians from France. I mean, there's a lot of people that went into standing on shoulders, essentially, of people who came before. Something else I want to share. Plague Incorporated. If you've not downloaded this is a fantastic game. You can just do the free version. And it basically, the point of it is you choose what you're going to be, and your goal of the game is to wipe out the human population before the humans can kill you. Right? It's a bit morbid, but the idea is very the same in that you're creating code. You're creating something to attack somebody else, and you're going to have certain defenses you're going to have to overcome, and those defenses are going to try and find ways of stopping you. One of his recent packs that you can download and install is starting the Ebola virus in the United States. Right? It's fairly timely. The interesting part is you will lose depending on how fast the humans decide to put news articles about what's going on, throwing money at the problem to get more scientists, because once you kill all the scientists that can read and write code, you basically win. Right? It's those people who live in Greenland or Madagascar that can survive because they don't have a lot of interaction with humans. So this is a great game to get you in the mentality of what happens on the offense side. Right? I like defense, doing the defense forensics, malware reverse engineering side, because I think it's harder, quite frankly. Offense seems to have kind of an open book of tools and techniques, and just waiting for somebody to make a mistake on not patching something to get in and take over everything. The hard part is finding that that patient zero and finding out if that's really patient zero. Is that where the infection started? Or once you get to patient zero, is there actually a different patient zero to find out when did this code come into existence? When did it start, right? So enterobacteriophage T4 virus. Entero means intestines. Bacteria is all over your skin. It's on your skin, it's in your bowels, it's all over your body. It helps you to live life. There's a lot of really good bacteria out there. The T4 virus, however, is something that how do I explain this? It's basically a syringe. So the code of this thing, and the code is all up in here. It's all the DNA, and it actually gets injected. It'll find the bacteria at the bottom, and it will inject the code into the bacteria and do some very interesting things. So I chose the T4 virus because I like what it does, and it helps me to visualize the design of how I designed my website, MalwareViz. Okay. So, excuse me. On your left side, you got the 2D version and the 3D version on this side. This is all from Wikipedia, so you can look at this as well. So the DNA is all the stuff in here, right? That's your code. That's what you want to look at. Protein's not a very good word of describing something, so instead of protein, think about scaffolding, right? So this is the scaffolding of that cell. When you get, I got my flu shot last week, and they injected H1N1 and two other flu viruses code inside of me. And the interesting that happens when you get that is scientists are basically taking this code, and they're able to actually cut out the part that reproduces itself and that can attack your body. So your body can find the T1 cell or the H1N1 and go, hey, I've seen this before. I've made a antivirus database entry for this. I know how to kill it, right? So it basically has a whole bunch of keys that it goes around your body with and says, hey, what cell are you? Do I have a key for you? I know what you are, I'm killing you. The problem is if your antibodies, your antivirus, internal antivirus, does not have that key, and you get an H1N1 that your body's not seen before, it tries all these keys and goes, I'm not sure what this is. So at that point, your body has to make a decision whether to kill it or just let it survive and move on. All right. So here is the life cycle of a T4 virus. Basically, it starts here. This in green is, that's the bacteria. The black circle is the code, right? So that's like saying that's your operating system, and here's your malware being injected into it. Once it gets to this point, the interesting thing is the code makes a decision. Scientists don't know why it makes this decision, but it has to make a decision. It chooses by the environment that it gets put into to do two things. One thing is it says, okay, I'm just going to go ahead and start breaking down that code, take over it, rebuild myself, and once I make enough of myself, I'm just going to send out some chemicals to thin out the wall and break out, and we're going to go attack the next bacteria, right? This is built into the code. The interesting part is right here, it may actually decide to wait till the bacteria itself splits into two. It's injected into the code, and lysogenic means to loosen, so it loosens actually the code of that bacteria in your body, injects itself, waits for it to split, and then go ahead and does the same thing. I love this idea because the malware that I find, that I deal with, it's built into the code as to, sometimes, it's built into the code as to what to do. For example, it will look for, hey, I don't know what operating system I'm on, but where's your temporary file, folder? So I'm going to go ahead and put myself in the temporary folder. Another example is it would say, okay, what version of Windows am I on? Am I on Linux? The first entry will say, what can I get to the internet? You'll see a whole bunch of internet traffic that says I need to go to Google or I need to go to Windows Update is a very popular one, because it wants to make sure I'm in an environment that I actually want to run into. Okay? If it can't get out to the internet, it's thinking, well, I may be in a virtual machine, somebody may be looking at me, I need to destroy myself. There's that word I wanted to throw in there. Apoptosis. I'll back up on this really quick because I really like this word. Apoptosis is kind of like Snapchat, where basically you're creating data that you have a time limit for, that you want it to die at a certain time. We don't do this. In our world, we collect everything and nothing's ever supposed to go away. But really, Windows XP has an apoptosis, right? Eventually, it's going to die. Stuxnet had an apoptosis where it said at this point in 2012, you're to delete yourself and go away so that we can deny that this was ever in existence. The other interesting point is how many people look across their enterprise what executables are in your temporary space or in your recycle bin. Okay? We don't really do this. However, malware survives there for years. And it's temporary. It's supposed to be temporary, yet we don't really focus multiple AV scanners on that area, and we don't dump it on a regular basis. So Zeus, other rootkits, toolkits know this, and they'll stick themselves in that environment knowing there's no apoptosis. There's no point at which you're just going to kill everything in a certain environment. So maybe we should start thinking about this. Is there data that we can actually do without? It would give us less to look at when we do forensics, and it may even protect us more. And it's already built into immunology, virology, this idea of looking at code that's already in biology, already in our own systems. And if we can learn to communicate that better, we can help better educate ourselves and the general population on how things work. All right. So there's your T4 virus. They called it a T4 virus because the first scientist to look under the microscope said, hey, this looks like a T, right? Pretty straightforward. It was the fourth one they looked at, so they called it T4. This down here is the basic design of my website. So anytime you run malware through MalwareViz, at the very least, you're going to see this design. So you kind of burn that into your mind. So what you're seeing is two things. The double circles can be either red or green. Red means, hey, I found something wrong with this. You really should take a secondary look at this. Built into the algorithm, the second node or pill or whatever you want to call that button is virus total. So if virus total finds anything wrong with this, the double circles will be red. It just says, hey, I already know this is malicious. However, and I'll show you in the next picture, well, let's just stick with this for a minute. There's your bacteria. You can see all the T4 viruses along here just attacking it like crazy. And for those reverse engineers or getting into this, I'll throw out the word mutex for a minute. What a mutex does is once you have one of these infect a bacteria, when you infect a machine, many of them will have a mutex, and that means mutually exclusive. I like to think of it as like the porta potties on the 4th of July down here at the mall, right? There's tons of them, but you know when one person's inside one. That's mutually exclusive. You don't throw a bunch of people into one. So like that analogy, when a piece of malware infects a box, Windows 7 or whatever, it is not going to allow another piece of malware to infect the same box. It says, hey, do you have a mutex? Yes? Okay, I'm not going to run. I'm going to close myself because I already know somebody's in there. I already know it's infected. So that's what a mutex is, and it's very helpful when you do reverse engineering. All right, malwr.com. This is also called, this is the online version of Cuckoo Sandbox. If you get into reverse engineering, you'll notice, not Sandia, Los Alamos National Laboratories uses this to do a huge amount of automated analysis. It's extremely well written. It's all Python. And if you get anything out of this, I hope if you've not considered learning Python, it's extremely helpful in a lot of the tools that are coming out that are extremely helpful. IDA Pro is probably the most popular one for doing reverse engineering. Its built-in language used to be their own custom thing. They've now put in a Python interpreter so that you can automate a lot of processes. right? So this is all built in Python. The problem being is I'm going back to that too much data problem. We've got so much data, and there's so many people that don't want to see all of this, that you have to ask yourself, okay, how do we explain this to a manager? How do we explain this to somebody just getting involved or doesn't even really care that much but wants to know the basics of what's going on? So what my site does is it tries to simplify this, and I'm very visual. I was dyslexic as a child, and I thought I was going to grow up to be a garbage man. I couldn't read very well. So visual, I love visual. Visual helps me out a lot. Visual helps me to memorize things and recognize distances very quickly. So what's going on here is you have your basic design. So this is green, saying VirusTotal is not seeing anything. It doesn't, that could be two things. Either one, nobody's uploaded this to VirusTotal, or two, none of the 50+ antiviruses in there see this. That's important to think about because there's Russian companies that their only purpose is to rewrap malware so that it does not get detected, right? So when we say, hey, your machine's compromised and we need you to do something, and they come back and say, well, we scanned it with AV, we didn't find anything. That's a huge problem, okay? Your AV is not going to detect this stuff. It's already been tested on tools like VirusTotal to make sure it doesn't get detected. In the underworld where you buy these things, they give you a promise. They say if this gets detected by any antivirus there, we will recompile it for you. We'll make another one for you so that we can still accept your $5,000 for this kit and you can go on stealing credit card numbers or whatever. All right, so what does the algorithm do here? This circle is red because of two things. You see an IP address go and traffic, and you see a URL. If all you see is a URL, think of adobe.com or java.com, right? There's files that will turn on, and their immediate thing to do is go to the internet to find out, hey, am I supposed to update myself? That's legitimate. That happens all the time. Malware usually has it built into the code to ask itself, hey, I'm probably going to get blocked once, twice, 3, 4, 5, 50 times. I need some way of getting around their way of blocking me. So anytime you have more than one callback, if it goes to the URL and then to the IP address itself, that's usually not built into regular legitimate software, right? To have it hard-coded to go to the IP address. So that is why the red circle turns red. It says, hey, you got too much network traffic going on here, okay? Created files is the forensic side, where anything executable, I gave it a secondary thing to do. I have to give a thank you to Carl from VirusTotal. When you create a VirusTotal account, you can do 3 automated scans a minute, right? They give you a key. You can use your key in a Python script and say, hey, I have 3 files a minute. It'll scan it for you. I explained to Carl what I was doing with my website, and he upped it to 30 for me because files that drop out of this, they may have not seen it yet. However, the files that drop out, many of them have already been detected by antivirus, right? So it gives that secondary check to say, oh, what it's wrapped in, I have no idea what I'm looking at. If it's been packed, encrypted, any word you want to use for it's trying to hide itself. It's basic text, right? So that's executables. These down here, I put into the algorithm a whole bunch of things that are important but not as important. For example, temp files, bat files, HTML logs. You may find this in the malware, but these usually don't have code that interests me. For example, the bat file many times will just be deleting the original file so it can copy itself to temp space, right? So you'll execute it on your desktop. Magically, it's gone from your desktop, but it's in your temp directory. And in Windows 7, it's for many people, it's hard to find the temp directory, right? Because it's not exactly, app data. It's not that easy to find always. All right, let's look at some. Okay, I'm going to give some thank yous, and then we'll do the live demo. And notice from these, all of these, except for MalwareViz at the bottom, this is Python. This is the advantage of Python. I've gone to every analyst and engineer in my environment and given them a 5 to 10 minute intro to Python because I want us all to speak the same language, and it just solves a problem of getting everybody on the same page to solve a similar problem. And it emotionally, emotionally, I have to say the word love. I love Python. It has solved so many problems for me and helped me to do so many things quickly. I don't have a programmer background. I studied international studies, global economics, which trained me for nothing, right? One of those social sciences, a college in Austria just axed their entire social department because they weren't training people to get a job where they could sustain themselves and not live off the government, right? So it's an interesting thought that you actually go to college to get a job. Anyway, I worked at a computer store, CompUSA, while I was getting my degree. So once I got into the real world, I went, well, the only job I can get is in computers. So then I went down the certification route, which, yeah, that's a whole nother rant. I have 14 certifications, and most of them have done nothing for me. So I looked at what really has done great things for me, and my Cisco cert and my CISSP have helped me. But Cisco cert was awesome. The CISSP, I don't want to offend anybody. I didn't feel like I was awesome at my job by having my CISSP, but it seems to be written into government contracts, so it's of value to somebody. So to that, I don't want to downplay it. You may need it for your career. MalwareViz, really quick, is an AT&T tool that can take your text file and create a SVG. SVG is a scalable vector graphic, thank you. Scalable vector graphics, and it's really helpful. A lot of the Wikipedia graphs you'll see, let me see if I can load this up. A lot of the Wikipedia graphs you'll see are SVG because it can go very small and very large without losing any pixelation. It looks very crisp, very clear. All right, so this is malware.com or malware.com. Ned and Jekyll, two guys, I think they're out of Brazil, have done great work. This thing was down for a month before my presentation, so I was panicking a lot about that. I'm like, well, what do I do now? So they got it back up, they upgraded their hardware. I sent them some money because I'm just like, please help me out, get this done. So anyway, off to your right here, I could put away my pointer. Let me tell you what we're looking at first. Sorry. Okay. Off to your right, this is all scene network traffic, and that looks really blurry from my angle. So hopefully, just visually know that these are all callbacks, okay? .net, .biz, .com. And this link right here will take you to that location. So let me show you. Now, I've not done this before. This is going to happen in real time. So I mean, I've done this before. That doesn't make sense. All right, so here we're seeing a domain. So this is going back to, got a bug coming at me, a URL, and then there's the associated IP address. Hopefully we have some drop files, no drop files. Well, let's do it anyway. So all I do is copy. Here's my website. VirusTotal, all they asked was that I put them on the front page. Very nice of them. Paste it in there, hit go. What's happening in the background is Python is great for scraping. Google uses Python to do its spidering, to index websites. So what it's doing right now is it's going to malware.com, grabbing everything, and then another tool, a Python tool called Beautiful Soup, is cutting it out and just getting what I want out of that. And of course, this is a live demo, so it's not going to work the first time. I will be patient. The only, Python is really fast, so the only speed limitation here is usually the network. So it could be the wireless from me to there. So Python Anywhere is where this is hosted, and Python Anywhere is great because it's an Amazon cloud. All the tools that you would load into this are already basically there. All you do is import your tools, import Beautiful Soup, import requests, import anything else you need, and it's done for you. You don't have to do any setup. And then they know you're going to be scraping other websites, so you can build scrapers to say, look, check whatever. If you're going to look at Bitcoin prices, right? Check Bitcoin and whatnot. And I know somebody probably hacked me this day, right? But let's grab another one while we're waiting. Is my internet even working right now? All right, let's grab another one. We'll just right click on this, copy the link. And, you know, failure is not that big a deal. Greatest things in the world have taught me usually when I've failed at something and versus doing really well at it. But this usually takes less than a minute, so I'm slightly concerned that, I'm slightly concerned that somebody has messed with my website. I'll give you an option. We'll ask. I can either go through and show you how I could fix this by showing you the actual code, or I could go back to the presentation. Code? All right, let's go with code. So first off, well, let me show you this. Web2Py, I chose so Web2Py versus Django or CherryPy or one of those other frameworks that you would use. I tried learning Django. Django is basically NewYorkTimes.com. It's all made in Python Django. Django's Python, Web2Py is Python. I had a lot of trouble understanding Django, and there were a lot of job advertisements for Django, so I'm thinking, oh, that's the standard, that's what I should learn. And it just, how my mind worked, it didn't work out. So I found an Italian guy who wrote Web2Py, and he did an awesome job, because all you do is download it, hit go, and it's just going to ask you for a password, right? And it asks you, hey, do you want it to be public or private or whatever? I'll just put in a password. And then boom, you're immediately online. That's it. That's all you have to do for Web2Py. And the awesome thing about that is you say, hey, I want to edit this page or whatever page, and it gives you a bunch of examples. So right off the bat, you have what are called controllers, which is all your Python script, and your Python is associated to views, which is your HTML. And the JavaScript, the organization, the CSS is already built in there for you. So it's really helpful in how this works. Let me see if I can start up another one. I'll probably get the same error. Actually, since I'm going to get the same error, let's fix it. I'm pretty sure I know what's wrong with it. So what's probably happening here is I automated this thing to scrape the crap out of malware.com. Just because, you know, I needed data. I was trying to do a scientific thing, and the end goal was to have a whole bunch of different images of what malware looks like and be able, from a 1,000 view back, to look at malware and say, this has the same code. It looks the same, right? The T4 virus looks the same. The H1N1 virus looks the same. The code may be slightly different, but the number of callbacks, how many executables gets dropped, and whatnot, look the same. So well, let me go to that before we go through the code. So here's recent. So here's some examples of what's going on. In the far left, you'll notice this did not work. So this is dynamic analysis that you have to say to yourself, okay, I have to do static analysis now. Why didn't it work? The great majority of malware you get wants to go home. It needs to tell somebody, hey, I was successful, right? So here's some more information to know. So for example, this one on the left did not work. You're going to have to do static analysis on that one. These other ones totally worked. You see the blue traffic, okay? All of that is network traffic. You see the files that dropped out. All of that tells you that's what you're going to probably find on that machine when you go and do your FTK or NCase or whatnot to find out what that is. All right, so here's the advantage of SVG files. Let me just bring up one of these. All right, so there's the basic shape. And remember, see how this one's red? It's maybe hard to tell with the white background. But this arrow is actually red. The rest of these are black. Because the original one may or may not have gotten caught by VirusTotal, all of these executables are a secondary scan against VirusTotal. This is the part where I say, hey, you know what? Check VirusTotal again to make sure this hasn't been packed in a way to hide itself. Now, here's what SVG does. Every single thing in here is clickable. If you click on the code itself, it takes you back to where it got the code at malware.com, right? So if you're a forensic analyst, if you're a malware reverse engineer, you want definitely deeper data, this is where you would start. You know, you need your MD5 hashes, you need your file size, you need the actual network traffic, other things that got downloaded to help you solve this answer. Strings, right? Strings are hugely helpful. It's a great starting point to find out, is there any English in here? If you see no English in here at all, it's packed. It's not going to show you anything. Your AV is probably not going to trigger on it at all, right? So let's go back here. Virus total, it has 10 hits. So this is the original file that dropped, and it still has 10 hits. When you click on it, it goes to the latest version. And we start saying, okay, riskware, toolbar, adware. Okay, so this may, so even though you may be able to one day read the code, read and write the code, whether it's your own genes through genomics, through human sequencing, or through computer code, through debugging, IDA Pro, Immunity Debugger, right? Once you can read through the code, you still have the problem of why, right? Even though if you can tell everything about this tool that works, why was this code created? And that's one of the hardest things to answer. If you can find out what was stolen, you kind of go, okay, they stole this. They're after your PII, or they're after your credit card number. That's why. But that's one of the hardest things, and the thing in the back of your mind that you should be thinking as you're trying to answer these questions. All right, so any one of these is also clickable, and then you'll see it dumped together a whole bunch of stuff that I really don't care about. I don't care about GIFs. I don't care about HTML, PNGs. I don't care as much about. Let me rephrase it that way. Words are very powerful, and I want to make sure I give the right words here. So I do care a lot more about the JavaScript, which can be detected by VirusTotal exe. So let's click on this exe right here. So it takes you to the MD5 of it, which converts it to the SHA-512 of it, and you can start getting more of an idea of what this is. This is adware, or a toolbar, or this is the type of stuff you'll be looking for when you start doing your analysis and investigation. All right. What about the callbacks? Where do they go to? You'll notice the arrows, some of them go just to the URL, and so you have, look, you got 1, 2, 3 arrows that go to this IP. So this very quickly can explain to a manager why we're blocking something. You say, hey, look, there's your malware. VirusTotal does see it as being bad, and this is why we're blocking those, okay? What we should also see in here usually is probably like this one, googleapis.com. There's always that legitimate, not always, in a lot of the kits, there's that legitimate, hey, can I get to the internet? Before I do anything else, before I unpack all of my C2s, all of my IP addresses and URLs to get more information, right? Before I put it in clear text in RAM, can I get to the internet? So once it passes that stage, usually, I always think of it mentally as a popcorn kernel, right? I don't want to chew on the popcorn. There's a lot of people that worry about what packer did it use, right? How is it encoded? How is it encrypted? RAM is the popcorn. Chew on the popcorn, don't chew on the kernel. I mean, if you can dump RAM at the right time, everything you need is in clear text in RAM. So any investigation you do, any investigation, get the RAM, get the RAM. And I had one case where I asked for that, and they shipped me the RAM, physically, right? So you laugh at that, but I have to take responsibility for that. We have to take responsibility for that as a cyber community, people who know how to speak the language, right? I have to take responsibility for that because I should have asked questions of, do you know what that means? If I don't take any responsibility for that and just laugh at them, the end user, then the communication is lost, and we don't help the environment by simply ridiculing a huge mistake, right? So I learned my lesson. When I say dump the RAM, I have to ask, do you know what that means? We have a tool to do that. We have plenty of tools to help automate that process. And people who worry about absolute forensics, unless you're law enforcement doing real forensics, you're incident response. You don't care so much about storing everything perfectly and getting the hand signatures and the MD5s. I dump RAM right to the hard drive and have them ship me the hard drive, because I don't care as much about what's in unallocated space, the free space, as I care about making sure I get the RAM. What's my time? Oh, crud. All right. Sorry, I had a lot to go through. Let's go to the bread and butter. All right, so gallery, analysis. If you want to see how I think about some of these things, I put in a whole bunch of analysis just to help you think through if somebody needs to start getting to understanding malware and reverse engineering, this is a great starting point. A lot of education here. Infamous malware, you have Stuxnet, Ouroboros. I have no idea if these are really Stuxnet and Ouroboros because a lot of legitimate malware has been uploaded to malwr.com, and some people who thought they knew what they were talking about has uploaded it and named it that, and they don't allow you to download to investigate yourself. Malware started to change that in that their default is to share with everybody instead of having to click on share with everybody when you upload your malware. I feel like I said that very fast. I hope that was... All right. So let's go to search. This page was really impressive because the creator of Web2Py made it like 3 lines of Python code. Like he did all of it for me. So basically, if you want to put in, hey, my tag is, what can I do with one hand really quick? Zeus, Z-U-S. All right, I have 214 entries that say it's Zeus, and I can go ahead and click on any one of these things to start finding out what it is. All right, so this viz query at the end, this is one of the main reasons I wanted to create MalwareViz. I wanted to very quickly look at a whole data set of different types of malware and see if I could say, hey, look, these look related. So I'll explain the one for, let's do APT. Okay, let's go down to the ones that say Mandiant APT. So Mandiant did a really good report in saying, so your MD5, your fingerprint of a file, if you change 1 bit from 1 to 0, the entire fingerprint's different. It's not close at all. They pointed out the fact that if you, instead of doing a fingerprint on the whole file, if you just do it on what are called import tables, or just, so like here's your whole file, if you just do the MD5 at the top, that will stay the same even though they change the callback or change files that get dropped at the bottom. And they listed their report. They gave it out and said, hey, here are the MD5s. So I said, okay, what if I Google that MD5? I Googled the MD5, and this is really small, I apologize. But I Googled the MD5, and MalWR had files uploaded to it with that MD5 as the import table. So I did pictures of these, and you'll see that 1, 2, 3, 4, 5, 6. These are all the exact same code, except they've changed the callback. And visually looking at it, you can say, well, wait a minute. These look the same. They're not dropping a file, except that one is and that one is. So there is some similarity, but some non-similarity. But very quickly, I can say, well, this might be the same code. We're at a disadvantage in that the kits being created mass-produce malware. So we used to be able to do static analysis on a lot of stuff, but when you can make 1 million different pieces of malware that automatically compiles itself with a different compiler and a different encoder, any word you want to use for hiding plain English, right? I mean, we're losing the battle. We need more people to make automatic tools that automatically help us to quickly make a decision and move on. The days of spending a week to 2 weeks on one piece of malware have to be over because we're getting our butts kicked. There's not enough people who know, we're code illiterate. We don't have enough people who can read and write code. And my hope and idea to you is, what are you doing to help people learn code in your environment? I mean, that may sound daunting, but when you have ones and zeros down here and English here, in my mind, Python is right here. Just get people's toe in the door. It's the closest thing to English than other languages. I'm not, if you want to do Perl or C++, whatever, influence your environment. The more people we have making tools to automate even one process, the more we're getting more to the automatic mentality, because static analysis, manually doing anything, has to be over. Our reports, I mean, anything we can do to save us even 1 second a day, and over an entire year, you've just saved somebody hours, right? Time travel is possible if you automate as much as you can do. So again, this is all free. You can play with this after, obviously, I fix the website. You knew it had to happen, right? I tried it this morning, and still problems. Zeus, adware, let's do an adware really quick. Let's do unknown. It's the database on this. I wanted to make this free, so if people wanted to download it, try it on their own machine, they could. Trying to take something that works just fine in the cloud and stick it on your desktop is a big pain in the butt, so I gave up on it. I'm sorry. It's still free, so you can use it online. So what are you looking at here? A lot of the green, these are unknown because none of VirusTotal saw any of these as being of interest. Either they didn't have it, or they, just, I have nothing in my database to say that H1N1 is bad, so why would I attack it, right? But as you can see, just by having these callbacks and all of these files that get put on your machine, these are bad, right? So there's a ton of these. I'll show you one really quick thing that I thought was interesting. Is this one does not look right. And one interesting thing about this is I'm like, why doesn't this work right? The file that was supposed to be connected to this, it has a file size of 0, but you see that up there? That's Chinese. I didn't build this site in Chinese. So I'm like, what the heck? How did that get to be Chinese? So the interesting part about it is there's already code built into Web2Py by the Italian guy who made this that allows you to automatically translate certain words. That Chinese right there is about, okay? So about is built in. So if the person who makes this malware, they ran it from their machine and their machine is Chinese. So it's interesting that it left a language signature as to who ran this piece of malware to make this graph. So I thought that was interesting. For those who think that's other interesting, if you've ever used PyScanner, it's built into Remnix, Lenny Zelster's reverse engineering class at SANS. PyScanner, one of the great things that I've used that for is it gets the 2 hexadecimal entries that will tell you if there's any language signatures. So if you find a executable, you can also find if there's Chinese, Russian, if there's, anytime you add an icon or any picture to a file, there's language signatures on that in the form of 2 hexadecimal bytes. And that's very helpful because the goal is to get into the mind of who created this. Where's patient 0? Okay, now that you know patient 0, who created this code, right? So all of this I find to be very, very interesting. Let's do this. Oh, not, okay. I'll end, I think, at 5 minutes. I was hoping to have some questions, so I'll just do this really quick. Powlix I find to be very interesting because this is malware that does not go on there's no executable. So what this is this is malware that has run DLL32. This is all in the registry. There's no code that's put on the box. It goes from the registry to RAM. Okay, so every time that thing gets turned off, it's really amazing. Wired did a great article about this. If you just Google it. So Powlix basically does, hey, JavaScript, I'm sorry, run DLL, then it does JavaScript. It sees if PowerShell is installed. If it's not, it downloads and installs it, okay? And then it runs the malware, which is in DLL form, okay? That is amazing to me. That is evolution. That is, there's, really quick, your body from your hair down to your toes, you have 100 trillion cells in your body, okay? Each cell has your entire code in it. That's 3.2 gigabytes. If you undo that yarn, it's over 6 feet long. That's 6 feet long times 100 trillion. I mean, it's baffling, phenomenal. But there's a ton of code in there that is not used. It's not turned on. So code can turn on and not turn on, and it can evolve. It can update, right? So it's really interesting to see how we update as code creators and developers. Every time some security tool comes out, basically you've just told the human mind somewhere else, here's a challenge. Find a new way of compromising me. So the game continues. Are we going to build a better catapult or a better castle wall? My hope and takeaway for you in all of this is that we really do need a lot more people who are literate at this, who will read and write the code, because it is phenomenally interesting. And as we get into Craig Vetter is making he's creating life, right? He's the one who, we sequenced the human genome. So basically we're getting to the point of, instead of doing dynamic analysis of human beings, where we see how we come out when two people get together, we're starting to get towards static analysis, where you can actually step through the code and figure out what it says. It's a one-to-one, from reading biological code to reading computer code. We're just reading code. We're trying to get something that's in a different language, as close to English, what we have an emotional connection to, right? Where we can add, the word malware means nothing to the great population, but if we say your computer has the flu, people go, oh, that's bad. I know the flu. The flu's caused me pain. I can associate, right? So communication is huge. So when you're talking with someone else who's not of our community, you really need to take some time to delve in to properly communicate the severity of what we're doing. And as Brian said, I don't want to downplay what we do, but where's the body count? And we talk about how important what we do is important, but there really is no body count yet. So I mean, I don't overly stress about this stuff, but I really want to do my best in my environment and help people. I do a lot of training for fellows and interns, and I want them to succeed at whatever they decide to succeed in. But also having a proper perspective of what we're doing. Security is very important, operations is very important, but it really is the fun of the path and the direction to which we're going. To that, I didn't get to the code. Sorry about that. Thank you for your time. I appreciate it. If you have any questions, I'd be happy to take those. And if some people aren't open to questions in a group setting, I'll be available afterwards, and I have some business cards if you'd like to have any private conversations, because in my world, it seems that I've turned from forensics malware reverse engineer more towards a teacher, and I've kind of enjoyed that hat. I like seeing people get to where they want to go and give them as many shortcuts as they can get to get there. So for that, I thank you for your time, and that's it.